This is the first of several sections of video that I'm going to be taking showing the conversion of this Rio Grande F3 USA trains to radio controlled battery operation with Phoenix P9 sound system. Step is to invert the engine and remove the shell. In order to do this, you need a long screwdriver to fit down in several holes, like the one here, here, and likewise at the back. The gas tank sound box will also need to be removed for placement of the speaker, and also to remove some of the screws holding the engine together. Now the 4 screws that were under the gas tank can be seen, as well as the plug for the speaker system. With the gas tank off, it's very easy to see the 2 leads that power the motor and also receive track power from the sliders and the wheels on the blocks. Then you can also see the switches for sound, front lights, rear lights, motor on off. These power connectors will not need to be disrupted. Carefully remove the hose units from the back of the engine. They extend far enough that they restrict the floor from being removed. Okay, this is the F3 opened up. As you come from the back, you have a weight. I probably will remove this weight to provide a place to put batteries. This is the first of 2 smoke boards. This smoke board feeds the forwardmost smoke unit. Here you have your main PCB that's hooked to the switches on the bottom side of the engine. You can see the MU plugs which come from the 2 motors. Here are the other MU plugs. Forward you have another weight, and you can see a regulator on the top side. Here you have the PCB feeding the lights with wires going back to the main board. Inside you have the contact switch that matches this contact for operating the rear light. You have the 2 smoke units with the second PCB for the smoke units located here. The first PCB for smoke units will probably be relocated to this position right here in order to make more room for the remote control unit. A jumper wire was made from the main PCB to the smoke unit that was relocated. The jumper wire was made long enough so that the locomotive shell could easily be removed for battery replacement. On the main PCB, you have wires that are marked motor 1, pickup 1, pickup 2, and motor 2. Each of those 4 sets of wires goes up to an MU style plug. That is the point at which the system will be intercepted to feed power from the receiver into the main board of the locomotive. A continuity test is done with an ohm meter to determine which side of the truck goes to the black and the red wires of the pickup. There probably will be reverse polarity by wire color between the front and the back block. so I'll have to check that. The frame was marked with black to indicate that that side is the negative side of the wiring coming up, or the black side of the wiring. The positive side will be marked with red to indicate the red wires coming from the pickups. The chassis was marked which side of the truck below has the red wire feed from the first motor, and also which one has the black feed from the first motor to this pin. Likewise, the back truck has it marked which is the red wire side, which is the black wire side. So when I build my wiring harness to control the two sides for a battery TrkPwr switch, then I don't reverse polarity accidentally. When positive voltage is applied to the black motor terminal, the truck pulls forward. When positive voltage is applied to the red wire or terminal going to the motor, forward direction results from the back motor block. The question might be, can I just turn off the motor switch and use that to isolate the locomotive from the track? A continuity test on the positive side shows that there is a minimum continuity on the positive side, both front and back. On the negative side, you see you have full continuity even with the motor switch off, both front and back block. As you must not depend on the motor switch to isolate either of the sets of wheels on the motor block. At this point, the decision has been made to completely remove the rear smoke unit. First step is just simply disconnecting the plug, which can be taped down in the roof of the locomotive. Next, the 4 screws holding the smoke unit and the PCB board will be removed. This weight will also be removed, making more room for various battery packs to fit underneath the shell while it's running. The intent is for this loco to be self-contained. With the weight and the smoke unit removed, I'll now fit the loco over the battery pack to check for clearance. With the battery pack in place, the loco can now hold the battery internally. The shell can lift off for exchange of battery pack in a very simple manner. Up to this point, all of the work has been generic on the F3. This particular set of work would apply to any self-contained battery installation. It really wouldn't matter whether you used Airwire, QIS, RCS, even a trail car battery system. From this point forward, the installation will be more specialized to fit the particular criteria that I want to make. Radio control, sound with control of the horn and bell run by TrkPwr, radio control as well. There will be more installations to follow. This is the end of part